Okay guys, so today we're going to be talking through lesson 3.7, and here we're going to be simplifying expressions. And to be doing that, we're going to be talking about combining like terms. I'm going to put that up here. So we talked in our previous videos a little bit about what like terms are. So like terms are anything that has the same variable. So for example, example 1, it says, write the simplified equivalent expressions for x plus x plus x and 2y minus y. So if we start with x plus x plus x, these are all like terms because they all have the same variable x. So we can just go ahead and combine them all together. So when we do that, we are going to have 3x. Now, the only way that we wouldn't be able to combine is if the variables were different. Like if we had a y here instead of an x, we would not be able to combine the y and the x because they're not the same. Or if we had maybe x to a power, like x squared, even though it's the same variable x, because it is squared and the others are not, we cannot combine them when we're adding or subtracting. So that would be the only difference, but since we have all three x's, we can combine. 2y minus y, so again, both y's, so we can combine. So we're going to go ahead and subtract. Now, anytime we see a variable by itself, like this y over here, you can always just think about that as having a 1 in front of it. They just took, it's just one y, but it's kind of unnecessary to have the 1 there, so they just take it off and just have it as y itself. But because we're talking about coefficients here, if we were to expand this, it would look like y, 2y's up here. So that is why it is a coefficient of 2. But since we just have one y, we can just put a 1 in front of it for one coefficient. So 2 minus 1 is just 1, which would be 1y, but again, we can just write this just simply as y to be more simple. All right, next example. So 4z minus z plus z minus 2z. So again, these are all z's. They're all like terms, so we can combine or simplify this expression. So we're going to use PEMDAS as always. So in PEMDAS, we do left to right with addition, subtraction. So first I'm going to do 4z minus z, which 4 minus 1 was 3. So we have 3z. And then we're going to, I'm just going to write all the rest of it out just so we don't get confused. So next comes addition. 3 plus 1 is 4. So we have 4z minus 2z, which is 2z. So that would be our simplified expression there. All right, let's try one more. So this summer, Vanna wants to charge 2.5 times as much for mowing and raking, but her expenses, which are $10 per weekend, will also increase 2.5 times. The expression below can be used to find how much Vanna will make mowing and raking X amount of lawns in a weekend. So we have 2.5 times 20.50x, so $20.50 for X amount of lawns, plus $5.50 times X. We could say this is for mowing and this one's for raking maybe. And then minus $10. That was her expenses that we had to take out there. So there's two ways that we could solve this. One, if you wanted to do the distributive property first, you could distribute this 2.5 to everything inside the parentheses, and then you can combine like terms, or you can combine like terms first. So if we were to do that inside the parentheses, we can combine the two x's. So we would have 20.50x plus 5.50x. So you would end up with 26x minus 10. Now, since there are no other x's, I can't do anything else in the parentheses. If this 10 had an x by it, then I would be able to combine those and subtract. But since it doesn't, they're not like terms, I'm going to leave it as is, and now I'm going to do the distributive property. So I'm going to have 2.5 times 26x, keep that subtraction sign the same, and then 2.5 times 10. So first 2.5 times 26, we have 65x minus 2.5 times 10, which is 25. And this is going to be my simplified expression. I can't do anything else. I can't subtract these two numbers because, again, they're not like terms. And the other thing I want to remind you guys while we're here is when we are multiplying a decimal by 10, like 10, 100, 1000, you can just move the decimal place over however many zeros there are that you're multiplying by. So in this case, there's 1 0. So in the move, oops, that should be 25, not 20, sorry. Since I'm multiplying by 10, there's only 1 0. I'm going to move my decimal place over one time, and that turns to 25. So if you're multiplying by 10s, 100s, 1000s, however many zeros that you're multiplying by, just move the decimal place over that many zeros. And that's going to be a little bit easier than stacking them up and multiplying them.